This is chapter 7.5. Use the triangle proportionality theorem and its converse. Your assignment will be pages 390 to 391. I'll give you the problems at the end. It's theorem 7.4, triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Okay, this is the guided practice. This is page 390, guided practice. And according to the theorem, if a line is parallel to one side of a triangle, if a line parallel to one side of a triangle, so the line that is parallel to the side BC in the triangle ABC is DE. If that line is parallel and it intersects the other two sides, so here AB and AC, then it divides the sides proportionally. And so now we're going to look at number 3. AD over DB equals blank over EC. So here's AD in yellow. Here's DB in blue. Here's EC in blue. Go ahead and write what you think is going to be your segment. Okay, segment AE is your segment that is proportional to AD. For number 4, we're looking at what over DA. So what over DA, DA is in yellow right here, equals CE, or CE, over EA, EA. So please figure out what your question mark would be. Okay, so we have BD, or DB, being the segment. Okay, now do number 5 and 6, then turn the recording back on to check and see if you got your answers correct, using the theorem 7.4 triangle proportionality theorem. Okay, for number 5, you're given AD, which is the yellow. You don't know what the other proportion is. Then you go over to the other side. AE is also the yellow. And then AC is the whole segment length. So AB would be your unknown proportional segment. For number 6, you're given BD, which is the blue. And you're given BA, which is the entire segment, both blue and A. And on the other side of the proportion, you're given CE, which is the blue. So to match it up proportionally, that would be CA or AC. Again, I like you to put the segment symbols even though the book does not. All right, we're going to move on now to numbers 7, 8, and 9. I'm going to be asking you to draw those pictures. If you want to do that, stop the recording and do that. You need to leave about 4 lines in between for work after you've drawn the pictures. Okay, in number 7, I've used a yellow highlighter to show that 8 is proportional to x and 2 is proportional to 3. Using the triangle proportionality theorem, we can find this value of x because we know that this line here is parallel to this line here, so one of the sides of the triangle. So 8 over 2, yellow, blue, to x over 3. Let's go ahead and highlight that. So 8 is the yellow, and x is the yellow, and 2 is the blue, and so is 3. Before we use the cross product property, we're going to go ahead and simplify 8 over 2 to 4 over 1. Then we're going to multiply, and an x is what some students think of it as. So 1 times x is x, 4 times 3 is 12, so x equals 12. All right, now let's take a look at number 8. Okay, theorem 7.5, which is from chapter 7.5, proportions in similar triangles. It's the converse, meaning the opposite of the triangle proportionality theorem. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. So let's look at a diagram of that. Okay, here we have triangle QRS, and you have a line, TU, dividing both sides of the triangle. So what they're saying is that if this TR is proportional to this RU, and this TQ is proportional to this US, then these will be, these lines TU and QS will be parallel to one another. So we're going to have to go ahead and write the symbolic. So here we go. In triangle QRS, if RT, that's the blue here, and RU are proportional, as well as TQ and US are proportional, then you will know that the segments TU and QS are parallel to one another. Now, it is kind of nice to know that you can actually have another way to do this. So let's just draw this figure again, and I'll show you another way to look at it. So in this figure, this triangle QRS, again, we're going to look at what's proportional, but I could make these two proportional to one another, and then these two proportional to one another. And so I looked at TQ to TR. Let's go ahead and write this. So if QT is proportional to TR and SU is proportional to UR, then TU will be parallel to QS. This is the method which the book shows you. However, I did want you to see both methods for the converse of the triangle proportionality theorem, which simply says if you have sides that are proportional, then those two segments that you see in your picture will be parallel. Chapter. The last thing, triangle 5, proportions in similar triangles, is finding the length of the midsegment of a triangle. The midsegment is a segment that connects the midpoints of two sides. Theorem 7.6 directs you with this. It says the segment connecting the midpoints of two sides of a triangle is, okay, it's going to be two things. First, if you look at DE, you'll see that that's your midpoint. It's parallel to the third side. And second, it's going to be half as long as the third side. So we'll go ahead and write a couple more. And your notations are as follows. Segment DE, which is the midsegment of the triangle, is parallel to segment AB. And segment DE is half as long as AB. So if you take half of AB, and you'll get DE. Another way to do this, it doesn't give this in the book, but is to take AB, divide it by 2, and then that will equal DE. Most students tend to like that a little. You can tell that this is, in fact, the midsegment because AD is congruent to DC, and BE is congruent to EC, which means that segment DE is, in fact, hitting the midpoints right here, the midpoints of both of them. We're now going to do, before we go ahead and do the checkpoint activities, we're going to finish up with page 390, number 9. I had forgotten to do that. So if you would please draw a picture of that. You've got a triangle. You've got two parallel lines. You know they're parallel because you've got a portion here. This right here is congruent. This segment here is congruent to this segment. This segment here is congruent to this segment, which means that you know that they're parallel. That's not what it's asking for. You know that this segment here at the bottom and this segment here are parallel. But you also know that this mid-segment, that's what this is right here. So that 4 is a mid-segment. You know that the mid-segment is half of the third side of the triangle. And so 4z would equal 4 times 2 to get back to what the actual third side of the triangle, which is 8. Now we're going to go ahead and do the checkpoint activities and see how you did. Okay, on number 1, the checkpoint activity on page 388, you're given a triangle. You know that this segment is parallel to this segment, and so we're going to determine what the value of x is. You will know. from the theorem 7.4 triangle proportionality theorem. So you can do it two ways. We're going to show both of those ways. The first way is going to be 4 over x. Okay, 4 goes with 5, so 5 over 10. We're going to use cross products. Okay, and before we do that, though, we're going to simplify the 5 over 10. So it's 4 over x equals 1 over 2. We're going to use cross products. 1 times x equals 4 times 2. X equals 8. Okay, here's the 4 and 5 are corresponding parts, and x and 10 are corresponding parts. And since we already know it's proportional, you can go 4 over 5 equals x over 10. Again, you're going to use cross products in both situations. And you're going to go 5 times x equals 4 times 10. 5x equals 40. Divide both sides by 5. X equals 8. You get the same answer, just okay, and then on this one's a little bit more challenging because we don't know what this is right here. And so in order to be able to work with this, we've got the whole side here, y plus something. We've got that whole side. But what we're going to need is we're going to need 15 and 6 because that'll give us the whole side, which is 21. And so we can go y to 14, so y to the whole 14. Y corresponds to 15. So 15 to the whole thing, which is 21. And then we're going to simplify before we use cross products because my math will be simpler. Both of these are divisible by 3. 15 divided by 3 is 5. 21 divided by 3 is 7. So now we're going to go 7 times y. We're using cross products. That's that cross product property. And equaling 14 times 5. So we have 7y. 10 and 5 is 50. 4 and 5 is 20. 50 and 20 is 70. Use the division property of equality. Divide both sides by 7. And y equals 10. So your y value is equal to 10. The figure in number 3, the triangle in number 3, what we're trying to ascertain is whether QR, and that relates to theorem 7.5, the converse of triangle proportionality theorem. If a line, RQ, divides two sides of a triangle proportionally, then it is parallel to the third side, TS. So we have to see if these are divided. And so again, we looked at 15 over 21 equals 17 over 23. 15 and 21 need to be proportional to 17 over 23. We're going to, if you can't look at it and just know that they're not proportional, you could use cross products. 15 times 23 is 345. 17 times 21 is 255. They are not equal. Some students will be able to just look at the original and say, no, they're not proportional. So no, the reason that these are not proportional is that RQ is not dividing the two triangles proportionally, therefore they cannot be. One more time, the question is QR parallel to ST, the segment that's dividing the two sides, parallel to the third side of the triangle? No. RQ does not divide the two triangle sides proportionally, so they. In the figure in number 4, we're whether QR is parallel to ST. So we've taken 4 and 6, those are to see if those are proportional to one another, and 8 and 12 to see if those are proportional to one another. We simplify them. They both simplify to 2 over 3, which means they're proportional. So yes, they are parallel because PQ compared to PR equals QS compared to RT, which is theorem 7.5, converse. In 5 and 6, we have to find the variable. Have a midsegment that cuts a triangle, that the third leg of the triangle, that the midsegment. And so you can see that half of 16 is 8. And then over here, you're given the midsegment Finding the perimeter